ให้โอกาสให้เกียรติกับทางบริษัทได้เข้ามานำเสนอสินค้านะครับเป็นสินค้าตัวใหม่นะครับเป็นนวัตกรรมใหม่รอบหนึ่งตัวอัลตราซาวด์ตัวนี้นะครับเป็นเรียกว่าเป็นท็อปแรงของโลกในขณะนี้ที่อัลตราซาวด์นะครับเพราะเป็น high definition นะครับขออนุญาตนะครับวันนี้เราได้เชิญคุณประเสริฐนะครับในส่วนประเด็นท่านเป็นVP ของบริษัทคอนเวนได้จะเข้ามานำเสนอพรีเซนต์ว่าของเราเนี่ยมีความมีฟีเจอร์ที่ดีมากๆนะครับ Hey, can you please show your presentation, please?
Good afternoon, doctors and nurses, ladies and gentlemen. My name is Tonette Penascosa, and I'm from Sonomed Escalon. And Sonomed is a company that's been around for a long time in ophthalmology, especially specializing in ophthalmic ultrasound. And I'll have to hold this microphone because this records the video. We have been around for a long time, and I'm sure a lot of you are very familiar with Sonomed, and for ultrasound, A-scan, B-scan, AB-scan, UBM, oximeter, and all those. I'm here today to basically present a new product that we have, and I would like to thank our exclusive distributor here in Thailand, New Eye Company, headed by Mr. Joe here. And thank you for taking time out here to listen to our presentation and also to see the actual device. So what I prepared here is just a short presentation on the product. So basically, VuMAX HD is a high-definition ophthalmic ultrasound, and HD for high definition. Now this is a picture of the unit, and we have the actual system over here behind me. And so it's a fairly new product. It's been released about a year ago, and when it came out, it showed itself as the best performing multi-frequency platform available in the market today. So which means you can actually have different probe frequencies on this particular ultrasound device. So this particular product gives you the flexibility of having different configurations depending on what your requirements are. So you can have this product in any of the following frequencies or models. You can have it as a B-scan only, you can have it as an A-scan and B-scan, or a UBM only, or a B-scan with UBM, or all the three frequencies, A-scan, B-scan, and UBM. So as you can see here, the biggest one is this one here. The topmost model is this A-scan, B-scan, UBM. So that completes the whole frequencies of the system. So it's really up to you. It gives the users the flexibility to actually just have the configuration that they need. And the beauty of this is that you can, in the future, upgrade. You can add more frequencies later if you only have one frequency to start with. Okay, so now features of the product: innovative design with superior image quality, performance, and reliability. So the key point and the key aspect of the product is the image quality, and you will see that later on once we do the live demonstration on the B-scan image, for example. So the image quality being high definition, which is very, very unique. It's the only ultrasound for B-scan images with high definition image quality. So the frequencies available is your UBM 35 megahertz. You can get an option of 50. B-scan, the standard one is 12 megahertz and optional 20 megahertz. And for A-scan, of course, your standard 10 megahertz. It is upgradable to different model configurations, and so which means if you start with a frequency, any of this frequency you start with, you can upgrade later. Okay, you can upgrade later. And for the A scan as well and B scan, if you have an A-B scan, you can add UBM later. Or if you have a UBM only, then you can add an A scan or B scan later on. So it's always that sort of room to scale up or upgrade to add new frequency. Okay. Now, customized presets for all frequencies, bringing the best resolution. So that is also, again, a unique feature of this product compared to the competitors, where the user can select if they want to do a retina image, retinal B scan, they select retina, and they get all the parameters already set up. No need to adjust gain, no need to adjust angle. All those things are already preset. If you want to do look at only the anterior side or perhaps the orbit, that also has a different fixed preset setting. Okay, so make it a lot easier for you and give you the optimum image quality. So that's the hardware and software platform is very innovative. It's based on a Windows 8 operating system and a very powerful system inside that box. Through high resolution display, so the display here is a high definition display, 1920 by 1080 pixels resolution. Intuitive interface, so the software side is very easy to use, very user friendly and compliant to all the current requirements in privacy protection. We have a function called auto tracking and auto measurement. So again, this is very unique on the product. None of the other ultrasound, V-scan and UBM, particularly UBM, has this particular feature because this is very useful for UBM imaging. What it does, it automatically measures and tracks while you're doing a scan or after the scan. It automatically tracks your corneal thickness and measures it, and also your ACD, lens thickness, angle to angle, and sulcus to sulcus. So while you're doing a scan or after the examination, if you enable this function, it will give you automatic measurements on all those parameters. Okay. For UBM option as well, there is a sizing nomogram available for ICLs. I'm sure this hospital, your department, do quite a bit of phakic IOL implants, and this is very useful. And the method that to size and determine the size of the ICL, for example, is by sulcus to sulcus, which has been proven to be very effective, giving you better clinical outcomes. Built-in angle analysis software, this is very useful for our glaucoma practitioners, and it has a special built-in software that quantitatively analyzes the angle image. So it gives you angle recess area, ARA, and angle opening distance, AOD. So all those parameters, not only giving you in degrees the angle, but it's giving you more quantitative parameters for analyzing angles. So that's also built into the system. Later on, we will show you these three functions here, and I will demonstrate that to you. The next one is the system is designed for our image management system called Axis, and which is also DICOM compatible. Okay. Full connectivity. So this system can connect to your network via Ethernet. It has USB 3, 5 USB ports actually. It has a dual band Wi-Fi. It has HDMI, Bluetooth. You can have all those connectivity from this ultrasound. So, B-scan biometry is a future option. We are currently working on developing this function there, but you can get it hopefully in the next few months. Option for B-scan biometry. So as you can see here, it's compact single unit console with smaller footprint. And as I mentioned before, A-scan, these are the frequencies available. And you can upgrade, you can start with A-B scan or B-scan only or UBM only, and later on upgrade it, add more frequency if you want. The resolution is there, as you can see, very high resolution images. Okay, the ultrasound, display resolution is there, runs Windows 8. You have a big screen right here, and it has a hard drive storage, what we call RAID system, which means one hard drive stores your patient data, and the other hard drive creates a mirror image of that data. So you never lose any data. If the system crashes, for example, then you still have a mirror image, a copy. That's why there's 2 hard drive systems there. So applications, of course, for this particular system, because it's A, B scan, and UBM, so basically it caters for for most specializations here, subspecialty. Cataract refractive for lens implants, phakic IOLs, ICLs, accommodating lens, multifocal lens, pre-op and post-op. Okay. Glaucoma, looking at angle, ciliary body, very important, ciliary body evaluation, angle analysis, and also post-op filtration surgery. Retina, of course, because this has B-scan, so you can do all your B-scan, ultrasound B-scan here. And also for the anterior segment, because it has also a UBM. UBM can do anterior, looking at the anterior chamber, some cornea and stuff. So I'd like to show you quickly some B-scan images here. This is an image from the system. It actually looks different because of the LCD projector. It may not give you a very clear image, but later on we will show you these images on the screen here. Okay, just to give you some idea. And so this is a live video of a B-scan image. As you can see, the resolution right there is very clear. Okay, you can see this mass here, and you have your vitreous. Okay. And also here is another image, so you can see some tumor and a bit of detachment right there. And here is also another case examination sample image. Okay. Okay, so we have a detachment and hemovitreous problem here. This is a UBM image. Okay, so as you can see here, we have the anterior segment. Okay, and then you can save. That's a video clip, and you can save the video clips here, and you can save the thumbnails. This is also a UBM image. Okay, so you can see it's very clear. Shows you the cornea. Whole anterior segment from one side to the other side, iris, sulcus to sulcus, you can see angle to angle, sulcus to sulcus right there. And the most importantly, this is something that not a lot of UBM machines can do, and that is to be able to show you the posterior lens. This is very important. You need to see the posterior lens in any anterior segment imaging. Very important. Why? Because this tells you how well you are aligned. You need to be able to see a full aligned image. And without seeing the posterior lens, you really are not sure, you're not 100% sure whether it's a well-aligned image so that you can do your measurements correctly. Because if you don't see the posterior lens, you won't be able to do your measurements correctly, especially for sulcus to sulcus, okay, for ICL sizing. But here, as you can see, it goes right beyond posterior lens, and then you can see in the actual image on the screen here, you'll be able to see, you can't see it here with the LCD projector, but you'll be able to see the zonules. You can see some zonule images here, the ciliary body and the muscles. So you see all that. Okay, so UBM, great for seeing what's under the iris. Okay, if you compare this with OCT, anterior segment OCT, which you have, Visante, for example, you'll only be able to see up to the iris. Okay, and that is very difficult, especially for glaucoma applications. You don't really know what's going on, but you need to see what's under the iris and the ciliary body and so on. So it's very important to be able to see what's under the iris. Basically, UBM gives you much more information, put it that way. Much more information and much more use for all the subspecialty as well. So here is an example of examination UBM, as you can see here. Nice image, very clear posterior lens. Okay, so you can see the posterior lens right here. And you see the zonules, you can almost see the zonules, ciliary body, and whole anterior capsule right here, the lens. Okay. Now the focal point is here on the iris. Along there is the focal point, which is the most clear and most visible and most clear part of the image. You may want to, I'm sure some of you may ask, why is the cornea shaped like that? You know, pointed cornea. And that is only because that is out of the focal zone of the UVM. The focal zone, the focal area is here. So if you're away from the focal, obviously your image will be distorted. But that's okay, because you're not looking at the cornea, you're looking at the iris plane. That's what you're imaging. You want to image the iris plane, you want to image the sulcus. So if you want to see the cornea, then what you do is get the image down, okay? When you do a scan, bring the image down, and you will see a nice, very round shaped cornea. When the image of the cornea gets close to the focal zone here, then you will get that. Okay? So a few more. This is post-op, as you can see, after implantation of lens. That looks like an accommodating lens, actually. Looks more like a crystal lens. Here's another accommodating lens called, I don't know if you've heard of this, WIOL. It's a European-made lens. It's a new accommodating lens. I did this image because they're doing a clinical study in Manila at one of the eye institutes there. So it's a WIOL lens, and it's supposed to, as you can see, the shape, the bottom part of that lens shaped like the lens capsule. That's the whole idea. There's no haptics; it just sits in the lens capsule. Okay, and this is how UBM, this machine, can be very useful. You can do all these things. Any new developments in lenses, for example, do pre-op and post-op evaluations. Sample of the angle, as you can see here, that's an image of the angle, very clear. This is done with a 50 megahertz transducer. Okay, and as you can see, you can actually see the separation line between the sclera and the ciliary body. Okay, that is something also difficult to image in any other UBM systems around. Very difficult. So here we can actually see that. You can see the back muscles here, part of the lens capsule, whole ciliary body right there. And this is just one image of the angle. It's a video clip of the angle, as you can see, nice and clear. See the separation line between sclera. Now if you follow that line, the sclera line over here, you follow that until it comes out of the angle. When it comes out of the angle, that is your sclera spur. Sclera spur is very difficult to pinpoint, to find, but doing this UBM at the angle makes it quite easy. Now I'd like to, as a final slide here, I'd like to show you the comparison between two frequencies of UBM, ultrasonic biomicroscope UBM. The standard frequency we provide with the machine is at 35 megahertz, but some users, some doctors would prefer a higher frequency because they do angles. So we recommend when they do a lot of angle images that they use a 50 megahertz because shorter penetration of the ultrasound when it's a higher frequency. Okay, so but you get a bit more resolution. As you can see here, the resolution difference. This is a 35 megahertz, which is very good by itself already. It's also very good general purpose frequency in UBM. But if you compare it with a 50 megahertz image, you can see the difference. It's not as bright. However, you see more detail. See the separation line there compared to this? Okay. That's the sort of detail that you'll get. Okay. If you have in a big hospital environment, I would recommend also having the 50 megahertz in addition to the 35 megahertz. Okay. Well, that's pretty much it. Thank you very much. We'll do a live demonstration. We'll do scan on the unit. I believe we'll do a B-scan, right, Mom? Maybe we can set up. What we're planning to do is maybe do put the machine over there so we can connect to the LCD projector so everybody can see the image while we're doing a scan. Okay. So we have this main database. All your patients will be here and all your scans will be here. So if you select a patient, for example, this particular one, all the scan of that patient will be listed here. To do a new scan, okay? Now we have a UBM connected. This is a B scan. So we have a B scan, and that is 12 megahertz. Okay? So this is the B scan. And if you want to do UBM, it's very easy. You just disconnect, you put a UBM probe, and only goes one way. That's it. So you have a UBM. Now this is a 35 megahertz transducer. If you want a 50, you basically unscrew that, and you put a 50. So that thing we showed you here, we have a 50. So you just finger tight. That's it. Open probe. We call this open probe for UBM. For B probe, B scan, it's sealed, closed probe. Okay, you need that. Now, for this one, for the UBM, we use to do the scan, we use an eye cup. Okay, so we have 3 sizes of this water bath immersion. So you basically just put this on the eye, open the eye, put this on, you put PSS, but anesthetic first, of course. So you put PSS and then immersion. So this probe goes in. As soon as it touches the water, you will see image. So then you do the scan like this, move it as you do the scan to align the image. Okay, that's one method. The other method is called what do you call this? Clear scan. Oh, here. Sorry, he's holding it. I've got it. So this is clear scan. So you put water inside. Normal water is okay. Drinking water is okay. Here, and then you put that there. Okay. So you can then open eye and then do scan like this. Much easier, quicker. Patient don't have to lie down, only sitting like this, and he can do scan like that. So you can do scan like that, easy.